dark matter. Everyone has heard about it, but no one knows the slightest thing about it. So if nobody knows anything about it, how do we know it exists? Dark matter is matter that does not undergo any electromagnetic interactions and therefore does not absorb, emit, or reflect any light and is therefore completely dark, and we think it accounts for 26% of the matter and energy density of the universe. Visible matter, also called baryonic matter, is made up of baryons, an inclusive name for subatomic particles such as protons, neutrons, and electrons. Scientists can only speculate about what dark matter is made of. It could be made up of baryons, or it could be non-baryonic matter, that is, matter made up of different kinds of particles. Most scientists think that dark matter is made of non-baryonic matter. Neutralinos, massive hypothetical particles heavier and slower than neutrinos, are the leading candidate, although they have not yet been detected. But what is a neutrino? Although the word atom means indivisible in Greek, it is not indivisible. Atoms are made of protons, neutrons, and electrons. They in turn are made up of the elementary particles, the down quarks, and the up quarks. We divide matter and antimatter into two groups: quarks and leptons. The difference is that while leptons can exist on their own, quarks have to exist together with another quark. The particles that make up matter are called fermions. The particles that make up antimatter are called antifermions. I'll explain antimatter in another video, so for now we'll just focus on matter. As you can see in the table, neutrinos are in the lepton section. Neutrinos do not interact with normal matter and are invisible, so they are very difficult to detect. In fact, millions of neutrinos are passing through your body as you watch this video. Because of this property, neutrinos are also called ghost particles. But if neutrinos are invisible and don't interact, how do we know they exist? At the end of the 19th century, a phenomenon called radioactive beta decay caught the attention of physicists. This reaction seemed to violate the laws of physics. The law of conservation of energy did not work in this reaction. According to this law, the products of the reaction should have the same energy as the reactants. But this was not the case in this reaction. The energy produced by the reaction was less than the energy of the reactants. Then in 1930, Wolfgang Pauli, a theoretical physicist, showed that this was not the case and that the energy lost during the reaction was due to an unknown particle. They named this particle neutrino, which means little neutral ones. There are three known types of neutrinos. A fourth, the sterile neutrino, is proposed as a dark matter candidate. The sterile neutrino would only interact with regular matter through gravity. We cannot see dark matter. But if we cannot see dark matter, how do we know it exists? The answer is gravity, the force exerted by objects made of matter that is proportional to their mass. Since the 1920s, astronomers have hypothesized that the universe must contain more matter than we can see because the gravitational forces that seem to be at play in the universe simply appear stronger than the visible matter alone would account for. You know hurricanes. Events made up of disconnected parts, like hurricanes, spin faster on the inside than on the outside. Think of it this way: all parts of the world are tightly connected. But hurricanes are not. Hurricanes are made up of air molecules that are independent of each other. The inner parts of hurricanes spin fast enough to cover an angular distance of 3 degrees per minute, while the outer parts can spin at 1 degree per minute. This is because the frictional force between the parts of a structure made up of dispersed parts like gases is not strong enough to equalize their angular velocities. We can see the same situation in the solar system. In the solar system, the inner planets rotate faster, while the outer planets rotate more slowly. This is because the solar system does not have the density of matter to equalize the force in the inner parts with the force in the outer parts. The same should be true for galaxies. After all, this is a law of physics, and the laws of physics apply throughout the universe. Isn't it? Well, it's not exactly like that. In reality, the inner and outer parts of galaxies rotate at roughly the same speed. It's like there's something out there, but we can't see it. That stuff we can't see is what we call dark matter. The evidence for the existence of dark matter is not limited to this. Massive objects such as stars and galaxies can bend the light coming from stars, making them appear farther away. How much this bending happens depends on the mass of the object bending the light. But when we observe the object and measure its mass, we can see it is impossible for it to bend light that much. That means there is a substance there that we cannot see. The bottom line is that we don't know what dark matter is. Some physicists think it's a mistake in the formulas we use. Others think it's one or more subatomic particles coming together to form dark matter. But we don't know. I think we need some time to figure it out.